Hi, I'm going to create this video based on the dot convention and mutual inductance. Okay, so mutual inductance is always there as long as there are two coils placed by side. Okay, so here I'm going to label them coil 1, coil 2, and coil 3. Okay, so I'm labeling them as 3 coils. Okay, so 2 important points you need to know. If current passing through one coil, then EMF induces across the second coil. So I'm talking about this. This is one of the important point. So because of the mutual inductance, if current passing through coil 1, then EMF induces across the second coil. And the second important point you need to know about the positive and negative signs of the induced voltage. So if current is entering the positive or entering the dot of a coil, if a current is entering the dot of the coil 1, then dotted terminal of the coil 2 is positive. Okay, so based on this, I'm going to write down the loop equations. Now there are 2 loops, so I'm going to label this as loop 1. I'm going to label that as loop 1, I1. Loop 2, let me change the thickness, that as I2. Okay, so now a simple way of solving this is, first based on the loop 1, apply KVL in loop 1. Okay, so apply, let me use the black color, apply KVL in loop 1. So if I apply KVL in loop 1, that's at 12 volts at an angle of 0. So I'm entering the negative terminal, so that's positive, negative, that's positive, negative, positive, negative. According to my I1 direction, I'm assigning those positive and negative signs. Now, so minus 12 at an angle of 0 plus J5 I1 plus J6 I1 minus I2. It's a simple loop equation without any mutual inductance. So you already learned this in the previous chapters, how to write a mesh analysis or mesh equation. So this is the mesh equation without any mutual inductance. Now we have the mutual inductance. J2 is between coil 1 and coil 3, and J8 between coil 1 and coil 2, and J2 between coil 2 and coil 3. So we know that if there is a current passing through one coil, there is an induced EMF across the another coil. So now if you look at coil 1, how many induced EMFs are there? There are 2 induced EMFs. One is because of the current flowing in coil 2, one is because of current flowing in coil 3. So we need to include those EMFs. So I'm going to label this as EA. So there are 2 EMFs, one is EA and EB. I will write down what is EA, EB in a minute. Okay, and so here is an induced EMF EA, and we also have EB. Okay, there are 2 voltages. So EA is current induced EMF because of current passing through coil 2. EB is induced EMF because of current passing in coil 3. I will write down. Now same way, you have 2 more voltages across coil 2, induced voltages. That's because of the current flowing in coil 1 and coil 3. I'm going to label them as EC and ED. Okay, so we'll end up with 2 more voltages. One is EB and we're going to end up two more voltages. One is EC and ED equal to 0. That's a given equation. That's the total equation. Now I need to find which one is positive, which one is negative. I will let you know in a minute. So let me pause the video. Okay, so we just learned that there are three terms because of the regular mesh analysis, and there are 4 more induced EMFs in that loop. So those 4 more induced EMFs are EA, EB, EC, ED. What is EA? EA is the induced EMF across coil 1 because of current flowing in coil 2. So I know that the top one is coil 1, which is J5 ohms, and coil 2 is J6 ohms in the middle. That induced EMF is J8 times I1 minus I2. Okay, so I know the magnitude. Now I need to find out which terminal is positive, which terminal is negative. So for that, we're going to use the first first point. If current is entering the dotted terminal of coil 1, then dotted terminal of coil 2 is positive. So if you look at here, I would say in any coil, okay, if you look at the first EA, so if you look at EA in the given circuit, okay, so look at I1 minus I2. Is it I1 minus I2 entering the dot or leaving the dot? So the dot, we need to look into the dot related to the coil 1 and coil 2. So those two dots are one right there, another one is right here. Okay, so based on this, so if you look at I1 minus I2, so here is I1 minus I2. Let me use different color. Okay, this one is I1 minus I2. Now I1 minus I2 is leaving the dot, so it's a kind of opposite side of this. So leaving the dot, so the dotted terminal is going to be negative. So this is the dotted terminal I'm talking about. So you will end up with this is negative, this is going to be positive. Okay, now look at EB. EB is also current flowing. So let me use blue. Current flowing in, induced EMF across coil 1 because of the current flowing in coil 3. Here current flowing in coil 3 is I2. That I2 is entering the dot, so the dotted terminal is going to be positive. So the dot, I need to look for this dot, so this is plus and this is minus. So based on this, you can see previously you have positive sign there, negative sign, positive sign. So based on this, we already have J5I1 as positive, so EA has the opposite sign, so EA must be negative and EB must be positive. Okay, now when it comes to EC, EC is the voltage across the coil 2. I believe that's because of the current flowing in. EC is the induced EMF across coil 2 because of current flowing in coil 1. That magnitude is J8 times I1. So we are finding induced EMF across coil 2 because of the current flowing in coil 1. So here I1 is entering the dot, so the dotted terminal must be positive here. So EC will end up this as positive, this as negative. Now ED is induced EMF across coil 2 because of the current flowing in coil 3. So I2 is entering the dot, so we're talking about this dot and this dot. I2 is entering the dot, so the dot terminal is positive here, negative there. So based on this, EC will end up with a negative sign there, ED you will end up with a positive sign there. Okay, so the equation, if I rewrite the equation again, or a complete equation based on this, equal to black equal to minus 12 at an angle of 0 plus j5 I1 plus j6 I1 minus I2 minus j8 I1 minus I2 plus j2 I2 minus j8 I1 plus j2 I2 equal to 0. This is my equation 1. Okay, this is my equation 1. Now equation 2, okay, I just redraw the diagram again here to avoid the confusion. So if you look at loop 2, apply KVL in loop 2. So we have 3 elements, so we'll end up with 3 voltages. So according to my I2, this is plus minus plus minus plus minus. So I'll start with the top element. So J10 I2 plus 5 I2 plus J6 I2 minus I1. So this is the regular equation. Now how many mutual inductances are there? Okay, so if you look at this J6 ohms, there is an induced EMF across this because of the current flowing in J5 coil 1. So I'm still taking this as 1 coil 2 coil 3. Okay, so if you look at 3 coils, so across coil 2 there will be 2 induced EMFs because of the current flowing in coil 1 and coil 2. I'm going to label that as E1 and E2. And same thing across the coil 2, there are 2 more voltages because of the current flowing in coil 1 and coil 2. I'm going to label that as E3 and E4 equal to 0. Okay, I will talk about which one is positive, which one is negative in a minute. Okay, so let me label E1, E2. Okay, so here is my E1, same thing, E2, and here is my E3 and E4. Okay, now E1, if you look at E1, what is E1? E1 equal to current flowing in coil 1 induced EMF across the coil 2 because of the current flowing in coil 1, which is J8 times I1. Let me write down the magnitudes and then I'll find out the positive or negative signs, so direction in a minute. E2 equal to J2 I2 and E3 equal to current flowing in coil 2 induced EMF across coil 3 because of current flowing in coil 2, that is J2 times I1 minus I2, and E4 equal to J2 times I1. So E4 is induced EMF across coil 3 because of current flowing in coil 1. Okay, now E1 is, we'll find out which one is positive terminal, which one is negative terminal. So if you look at E1, E1 is current flowing here, current is entering the dot, dotted terminal must be positive. So this one is going to be positive, that one is going to be negative. Now E2, current flowing here, so current is entering the dot, dot terminal must be positive, thus this is positive, this is negative. Okay, so if you look at here, E1 has the same sign of the previous element, so E1 must be positive. But if you look at E2, E2 has the opposite sign, so it must be negative. E3, similar way, so current is entering the dot, so the dotted terminal is positive, so E3 is positive here, negative there. And E4, current is entering the dot terminal is positive and negative, so these two are going to be positive. That's your equation 2. Okay, so I'll stop it here. Based on these two equations, you can find whatever the elements he's talking for. Okay, thank you.